A very good morning everyone. Welcome back to RKP online classes. Today we are going to do the topic of water. Water that we drink, that is pure water. Pure water means the water which does not contain any other material. If any other material is mixed in the water or is present in the water, that water is known as impure water. That water is known as impure water. Impure water means the water which is not pure, means which contains some materials. There are two types of materials which can be present in the water. One which can see, one which cannot see. For example, you are taking a glass of water from the tap of your house. From the tap of your house, if you have filled a glass of water, it will not contain anything that is visible. But do you think that water is pure and good and safe for drinking? No, that can't be good or that can't be pure for drinking. It must contain, would be having some material which is not good for our health. But how can we say that? We are not able to see those materials. Why are we not able to see those types of materials? Because they are properly mixed in water or they are properly dissolved in water. But if I say that collect some water from well or from pond, etc., in that you will see some tiny bits of leaves, some parts of plants, also some soil material, some stones that are properly visible. That water, we can clearly say that it is not pure water, it is not clean water. Why? Because we are able to see those types of materials. It means some materials which are present in water can be seen and some materials which are present in water cannot be seen. Why is it so? It is so because some materials are soluble in water and some materials are insoluble in water. What do you mean by the soluble materials and insoluble materials? Soluble materials are those materials which properly dissolve in water, and after dissolving we cannot see those materials, and insoluble materials are those materials which do not dissolve in water and we can see properly after mixing also. So which type of material are soluble in water and which type of material are insoluble in water, we will see by doing some activities. So let's do the activities. So let's start the activity. I will show you four types of material and then I will mix those materials into the water. Then I will stir the solution. After stirring the solution, you will see the difference between all the materials. Two types of materials I have already told you: soluble and insoluble. Soluble materials are those which mix in water properly, and insoluble materials are those which do not mix with water properly. So if they mix with water, how do they look after mixing? And if they do not mix with water, then how they will look after mixing? So let's do. Okay. So I have taken these four types of material. This one, stones, salt, sugar and sand. Sorry, soil. Soil, sugar, salt and stones. I will put one spoon of each into a glass. 1 spoon of salt, 1 spoon of sugar, and then 1 full spoon of soil. Now I will mix water in these four containers, and then after mixing the water I will make a solution. Okay, so let's see. So let's add water in the container containing stones. I am stirring the solution, means mixture of stones and water. You can mix the material in water or you can mix water in material. It means पहले material डालो फिर water डालो या पहले water डालो फिर material डालो, one and the same thing. So I have mixed this and stir it for few minutes. Now I have put water in the container containing salt. Water in the container containing salt. And I am stirring the solution. Now I have mixed water in the container containing a spoon of sugar. So this is the container. You can see clearly sugar at the bottom. So I am stirring the solution. Now I have added water to the container containing a spoonful of soil, and I am stirring the solution again for few minutes. Now after few minutes I have seen all the solutions back, and this is the first solution in which I have mixed some stones with water. You can see clearly stones at the bottom. See carefully. Stones at the bottom of the solution. It means these stones have not mixed with the water properly. They have not mixed with the water and they were heavier than water. That's why they have settled down. So it means stones are not soluble in water. So stones are the type of insoluble material, or we can say that insoluble impurities. So this was about first solution. Now check the second solution. This was the solution of salt in water. See carefully. This is the solution of salt in water. If we will look inside, look carefully. If we will look from outside, we cannot see the salt in it. I have dissolved both the things, stones as well as the salt, for the same time, but I am not able to see any salt particle in the water after some time. It means salt is soluble in water. Salt has mixed with the water properly. So salt is a type of soluble material, means soluble impurities. Impurities, the things which make water impure. So this was about second solution. Now this is the third solution. If we will look carefully, this was sugar in water, and if I will try to find out the sugar particles, I am not able to find out any sugar particle inside the water. Why I am not able to find out the sugar particle? Because sugar particles has been, this is not sugar particle, this is the dust particle which you can see clearly in water. So sugar particles are not visible in the solution because sugar particles, all the sugar particles have been dissolved in water properly. It means sugar dissolves in water. So sugar is a type of soluble material, means soluble impurity. This is the fourth solution. You can already guess which solution is this. This is the solution of soil and water. I have mixed a spoon of soil mixture and water, and I have stirred the solution. On the upper layer, above the water, you can see clearly small particles of that soil particles that we say as humus, dead parts of plants and animals floating over the water. And if you will look at the bottom, this clearly it is shown that soil particles have settled down, because these particles which are at the bottom, they were heavier than water. That's why they have settled down. And these particles which you can see at the rim of the water, means boundary, the upper layer, these particles are not settled down, have not settled down, because these were not heavier than water. These particles are lighter than water. The weight of these particles are lighter than water. That's why they are floating above the water. And these sand particles are heavier than water. That's why they were settled down. They have not mixed in the water because they are not soluble in water. It means soil is also insoluble in water. So this was all about soluble materials and insoluble materials. So four types of materials we have tested in water. This is the solution of stones in water, and this proves that stones are insoluble in water. This was of salt in water, and this proves that salt is soluble in water. This is of sugar in water. This proves that sugar is soluble in water. And this is of sand in water, and this proves that sand is insoluble in water. So by mixing like this, we can check whether a material is soluble in water or insoluble in water. Now, from this activity, we are also aware that some materials which are insoluble in water, some materials settle down and some materials float on the water. Which type of materials will settle down in water? Stones are settling down in water, and these soil particles are also settling in down in water. These are settling down in water because they are heavier than water. So the particles, these particles which are settling down, these particles are also known as sediments. These particles are also known as sediments. So sediments are settling down. So if we will look up carefully for this activity, the sediments which are heavier than water, sediments means particles which are heavier than water, are settling down in the water. So if they are settling down in the water, they are not dissolving in the water, can we separate them? Is there any method to separate the impurities from water? Four materials we have done here. Two insoluble materials and two soluble materials we have done here. We have mixed these materials in water, it means we have made the water impure. Is there any method to remove these impurities from the water? Yes, there are methods to remove the impurities from water. So let's start. Now we will start one more activity. This activity will tell you how to remove the insoluble impurities from water. We are having two types of insoluble impurities from water. One is stones and one is soil. Clear? So in previous few minutes before, you have seen the activity. I have mixed stones and soil in water, and I have left the solution for few minutes. After few minutes, we have seen that stones have settled down and clear water have came above. So the sediments of stones, the particles, stone particles have settled down, or the sediments have settled down. This process is known as Yes, this process is known as sedimentation. What is sedimentation? Settling down of heavier insoluble particles in water is called sedimentation. These heavier insoluble stones have settled down in water. This process is known as sedimentation. So when heavier particles will settle down, water will come above, and you can see clearly water is too clean. It means we have removed the impurities from water and the water is clean enough. See clearly, water is clean enough, right? So this process is known as sedimentation. So now we have made impurities settle down. But how to remove, means how to separate these impurities from water? To separate these impurities from water, we need one more container. Slowly I will pick this solution. Why slowly? If I will move this vigorously, then impurities or particles will again mix with water. And slowly I will pour this clear water into another container. So I have poured this clear water into another container. You can see the impurities in this container, and you can see the clear water in this container. This was about stones, and this was about stones. So the water was too clean in this container also. But what about this solution of soil and water? Let's do this also. So in this also, for this solution also, I need a container, separate container. You can see this soil particles, heavier soil particles settle down, and lighter particles present in the soil floating above the water. If you will see this water, this is clean before than earlier. When we have mixed the water with soil, that was too dark also now. But if we will see that soil particles have settled down, this is clean as compared to earlier. So what I will do, again I will pick this container very slowly, and then I will pour this solution slowly inside another container. If we will see this water, and if we will see this water, They both are having much difference. This is much cleaner than this one, right? So it means that this water contain less impurities as compared to this water. But in this solution we can still now see some impurities which are floating above the water. So what to do with these impurities? Still the water is impure. So these are also insoluble impurities. These are not soluble. These are also insoluble impurities. Fine. So but what we have done this, we have poured the clean water from this container into this container slowly, without disturbing the sediments. Without disturbing the sediments, we have poured the clean water from this container to another container. This process is known as decantation. What is this known as? Decantation. What is this known as? Decantation. Okay, so what we have done, we have done two processes. Firstly, settling down of heavier insoluble particles in water is known as sedimentation, and second is pouring this clean water into another container, which is known as decantation. So what we have done, sedimentation means settling down of heavier insoluble particles, and then we have done decantation means pouring of clear water into another container, which is known as decantation. Now the next activity will tell you how to remove this insoluble particles which are not even settling down and which are not even removed by pouring into another container. So we have done about sedimentation and decantation. In sedimentation particles were settled down and we have poured the clear water into another container, that is decantation. But what about these lighter insoluble particles? For this we have one more activity. What we will do, we will filter this out. These particles we will filter out, and that process is known as filtration. For filtration we need a filter paper, or if you are not having a filter paper, you can use a muslin cloth. Muslin cloth means malmal ka kapda. So how to do that? I will show you. I have kept a cloth above a container and I will make it like this. Then I will take that solution in which insoluble particles were there and I will pour this solution like this. Students, can you see properly all the insoluble particles? So can you see clearly these particles which are above the cloth? They are not gone along with the water. They are being separated above the cloth. They are being separated above the cloth. So this cloth has not allowed these particles to flow along with the water. So if I will show you the water at the bottom, means by removing this cloth has separated all the insoluble particles which were not separated by the process of sedimentation and decantation. These are filtered out and this process is known as filtration. So I am removing this cloth which is containing the insoluble particles. So look carefully, look clearly. No insoluble particles are there in the water. So we have got the clean water in the container. This process is known as filtration. So this is how we can remove all the insoluble impurities from the water. Three processes we have done. First was sedimentation, the decantation, and then filtration. Now it's turn to separate the soluble impurities from the water. Now to remove the soluble impurities from water, what I will do, I will heat the solution. So I have taken this salt solution. I will put this in pan. I have switched on the gas and the gas is at high flame. I will let this solution to boil for a few minutes. And you all know that after boiling, the water will change into water vapor. So I will leave this solution for few minutes till all the water from the container will change into water vapor. So let's wait for few minutes. After few minutes, I am going to remove the cover lid of this. I have removed. I can see clearly the water is boiling And now I will see let this water boil for a few more minutes, and I can clearly see the level of water has gone down. It means much amount of water has been changed into water vapor. So let's wait for a few more minutes. After a few minutes, I have observed some changes in this pan. If you will look carefully, can you see this white spots? These are the salt particles. These are the salt particles, and see the amount of water. It has been reduced to much amount. It means much of the water has been changed into water vapor, and see clearly the water is very less amount of water is left in this, and there is white spots at the pan is salt only, because when water was boiling, it came above, and the water changed into water vapor, but the salt particles stick to the pan. So the process here I am doing is boiling, and after a few minutes I will show you that boiling will separate the soluble impurities from the water. It means if we want to separate any soluble impurities, we have to boil the solution. During boiling, the pure water will change into water vapor, and all the things which were mixed in the water will remain behind. Students, see clearly, all the water has been evaporated and the salt is sticked to the pan. It means water is evaporated and salt is left behind. So water and salt are separated from by the process known as boiling. And if you want to collect the water also, you can collect by collecting the water vapors and condense it. Condense it means cool down. Look at the base of the pan. Some amount of water is still left, but we can see clearly at the base of the pan some white thing is present. This is the salt only, which was dissolved in the water. But you will say that, ma'am, salt is not like this. We have dissolved salt crystals in water, and now we can easily get the salt back, but the salt is not in that shape of crystals, because when the salt was dissolved, it was properly mixed in the water. The shape was deformed, shape uski khatam ho gayi thi because of mixing in water. The molecule shape mixed in the water. So now we have got our salt back by the process known as boiling. Now I will show you this salt. See, I have got salt back. So this is how we can separate soluble impurities from water. This process is known as boiling. So in this video we have done 4 processes. 3 were how to remove the insoluble impurities from water. That was sedimentation, decantation and filtration, and this was the boiling process through which we can remove the soluble impurities from the water.